Hello, hello, hello. Chapter 1, 1.1. Welcome to college trigonometry. So we got to start with the basics. Moving it back to the basics. First, we have trigonometry, which means measure of triangles. That's what trigonometry is. But we're going to get the patterns of triangles. All of that we do this semester is pattern of triangles. When we're talking about an angle, it's going to be an angle is going to be two rays connected at one point. This should be reviewed from geometry. So an angle. Now, when we look at an angle, we have an initial side, meaning the side that we typically write. Now, I'm going to focus right here. The initial side should always be this one right here that is on the origin with the positive x. This is my initial side. The terminal side is the other ray that is created. So this right here is my terminal side. Now, when you draw out an angle, you always start at your initial side going to your terminal side. So when I'm talking about the measurement angle, you start at the initial side, which should always be this line right here to the terminal side. Your vertex, when we're talking about trigonometry in an xy plane, should always be at the 0, 0. Vertexes, the two lines meet at a point. My standard position is right here is when we're talking about our xy plane. So here's our angle, here's our standard position, and this is what we're going to primarily be dealing with. We're not going to just be drawing angles on rogue and wherever it's going. Here that I just drew, this is a positive angle. When you are going from your initial side and you're going counterclockwise, that is a positive angle. Now, if I were to draw a negative angle, I start at my initial side because no matter what, you should start at your initial side. This right here would be called a negative angle. So this would be a negative angle when it's clockwise. And then we have our positive angle when it's counterclockwise. Counterclock. Okay, so that you can know the difference between when it's positive and when it's negative. Now, when in trigonometry, these are three ways that we typically will label angles. A lot of times we use theta. This is theta, beta, alpha. Okay, now coterminal angles. Coterminal angles. Now, if I'm going to draw this out, here's our xy plane. Again, when we draw out an angle, we're always going to draw our our initial side right here. When I talk about coterminal angles, let's say we have an angle right here. These two are coterminal angles just like, because the fact that from this, we have an angle at this measurement, we also have an angle at this measurement. Those are coterminal angles when they have the same initial side and the same terminal side. Now, you could also have a coterminal angle because when we're talking about angles, we can have an angle that's greater than 360. So if I had an angle that looked like this, bear with me, whoop-de-whoop. Those are all coterminal angles because they still all have the initial side. All of these angles start on the initial side and all of them end at this terminal side. Now, in trigonometry, we will have radian measure. Now, typically what we will be using, especially right now, is going to be using a radius when this is 1. But what radian measure is the angle of this degree. So this angle right here, when we're talking about degrees, it's the same degree right here. But when we're doing a radian measure, this angle right here in radian measure helps us represent what the arc is without doing more math, I guess you could say. It's always dependent on your radius. So again, because my radius here, I'm going to say my S in this problem, S is equal to R. Because my radius and my arc length are equal to each other in this case, then my theta right here is this length right here, just like how if it's in degrees. However, if we increase my r times 2, that's going to change my radian measure. My radian measure is always going to be dependent on this arc. So radian measure is if we were wanting to figure out the length, if we're going to make a baseball field, because that's what I'm thinking about right there. How big or small the baseball field, we would want to know the angle measurement in radians because that's much easier to find this arc length. So we use radian measure when we want to find this arc length with less computations. Now, when we're talking about radian measure, I know this is super small, but again, when we're looking at the xy axis, our radian measure in quadrant 1 is always going to be between 0 and pi over 2. So this right here is pi over 2, which is also 90 degrees. In quadrant 2, it's going to be pi over 2 to pi. So 180 degrees, which is a straight line, is the same thing as an pi in radian measure. And in angle 3, we have pi to 3 pi over 2. And in quadrant 4, we have 3 pi over 2 to 2 pi. So again, this is something that we will always be coming back to. So let's get into some example problems. So for this first one, it says for the positive angle 13 pi over 6, subtract 2 pi to attain the coterminal angle. So it's telling you right now to subtract 2 pi, because when we're looking up here, just like in this blue, when we subtract 2 pi, that's one full circle. Again, one full circle is 2 pi. So if I subtract 2 pi or add 2 pi, I'm basically adding a circle like this blue line up here. So if I'm going to do this, I want to do this in my brain, I need to change it so I have like common denominator. So this would be 12 pi over 6, because I'm multiplying both the top and bottom by 6. So in this case, this will be a pi over 6. Now I want you to pause the video, and I want you to try to do B by yourself. And we get 4 pi over 3. One thing, just to let you know, we will be working with these numbers so much that you will get to know what exactly these are. So first, question number 2, it says, if possible, find the complement. So complement means two numbers that add up to 90 degrees, but in radians, it would be two numbers that add up to pi over 2, because that is 90 degrees. Those are the same. And the supplement are two numbers that add up to 180, but in radians, it would be two numbers that add up to pi, because these are the same measurements. Again, it changes with when you know the radius. So if my complement, two numbers that add up to pi over 2, so I'm going to take my pi over 2 and subtract my 2 pi over 5. And you should get pi over 10 is my complement. Okay, because we're taking that 90, subtract the angle. So if I want to look for my supplement, I take my pi, subtract my angle. So this is the same thing that we do with our degrees, but now it's just in radians. And we get 3 pi over 5. Right now I want you to pause the video and try to do B by yourself. For the first one, you would have gotten a negative, meaning that there's no complement here. So if this ends to be negative, there's no complement. That's because this angle right here is greater than 90 degrees. It's greater than pi over 2. Because again, pi over 2 is your 90. Here, if I subtract it off, I should get pi over 5. So when we're talking about degrees in radians, we have this conversion that we can go in between degrees and radians. And what we always use is 1 radical, or pi radical. Again, when we're talking about using rad as radians, is equivalent to 180 degrees. Now we can use this either in this format or we can use it in this format, because those two are equivalent when my radius is 1. So this is a kind of our unit conversion, just like how 12 inches is equal to 1 foot. We could set those on the same equation, just like this. So if I'm looking to try to set this equal to radians, I'm in degrees. And if I want to make sure to have this in radians, I would multiply by the radians on top. So pi over 180. The reason we do this is because now my units of degrees, because there's one on top and one on bottom, those will cancel each other out. So in this case, I have 135 pi over 180. And because you are such a smart individual, you will never ever leave it like that, because of the fact that you can always reduce your fractions. So in this case, this is 3 pi over 4 radians, or rad. So right now, I want you to do B by yourself. And you should have got 3 pi radians. So same type of thing. Now I'm in radians, but I want degrees. So if I have this negative pi over 2 radians, what I will need to multiply it by, because this is in radians right now, is my pi radians over my degrees. So now these two units will cancel each other out, and I multiply across. So I have negative 180 pi over 2 pi. And again, you do not leave it like that. You would get the pi's cancel out, because those will multiply, so we can cancel those out, negative 90 degrees. So right now I want you to do B by yourself. And we would get 360 divided by pi. Here, the pi is canceled. Here, they don't. So we divide this out, because when we write in degrees, we typically do not leave it in pi units. When we leave it in radians, we do have it in pi units. So this would be a roughly 114.6 degrees. So now we have arc length. I kind of touched on this before, but our equation for arc length is S is equal to R pi, where S is my arc length right here. S is arc length. r is going to be equal to my radius, and my theta is equal to my central angle in radians. And this must be in radians, okay? This must be in radians to use this equation. So now, a circle has a radius of 4, so that means it's r. Find the arc length, so this equation right here, central angle in 240. Well, that's not in radians, so my first step is to put this in radians. So I have my 240 degrees times my pi over 180. That's going to give me my radian measure. So now this angle in radians is 4 pi thirds. So now my second step is using that equation. So my arc length, which I don't know yet, is equal to my radius, which is 4, times 4 pi over 3. Now again, when we're talking about arc length, we typically don't leave in pi units because people typically can't think in pi units. So this would be 16.76. Now, because this is in inches, again, length is one-dimensional. This is also in inches. So your units are always based off your radius. Okay, now we have linear and angular speed. This is something that I will give you. You don't have to memorize this. But when we're talking about linear speed, it's saying how far or how fast you actually travel. So linear speed, when you have a second hand of a clock, is 10.2 centimeters long. That's right there is giving us our radius because that's the measure from the center to the edge. Saying find the linear speed, so I know for sure I have to use this equation. The second hand as it passes around the clock face. So that means in one, if this is my initial, it's saying one full swoop. So right here, I know what my angle is also. One circle around in radians is 2 pi. One circle around in radians is 2 pi. So looking at this equation, saying my arc length, well, so first I have to figure out what S is. So my S, remember, is my radius times my central angle in radians. So 10.2 times 2 pi, that's my arc length that we just went over, divided by time. Now, when we're talking about time, we have the second hand. So if we're talking about the second hand, so every minute, we're talking about minute, but we want to change that to seconds, our time would be in 60 seconds because we're looking at the second hand. Remember, this right here is in centimeters. So now we're figuring out how fast we're moving in centimeters per second. That's what we're getting to. So if I simplify this equation, I get that the second hand is moving at a distance of 1.0, I'm going to round to 7 centimeters per second. Because again, as it passes around the clock face, so that's why it's the 2 pi, because it's one circle, that's asking per second. So every time it moves, how fast is it moving that distance? In question 7, the blades of a wind turbine are 116 feet long. So again, that's my radius. It rotates at 15 revolutions per minute. That's important there. Find the angular speed. So if we go back to this, we need our central angle. So again, our central angle is going to be the 2 pi because it's talking about how fast it's going around. However, it's saying per minute, it goes 15 times. We have to multiply this by 15. That's our central angle right here. And then because we have per minute, that's 1 minute here. So our distance is 94.24, actually this would be a 5, radians per minute, or you could also think of it as 30 pi radians per minute. So because we're talking about angular speed right here, we're keeping it in radians. That's why a lot of times you might leave your answer like this, because it's in radians units. Now it's asking to find the linear speed of the tip. So how fast is that linear speed that we're moving? So just like up here, we need to figure out our S first. So we have our 116, because that's our radius, times our central angle. Where did that 30 pi come from? Again, because of 15 revolutions per minute, and then one circle is in 1 minute. So if there's 15 times, we do one circle. Divided by our total time, which we are already talking about, is 1 minute. So this one, again, you would multiply out. And because it's a larger number, I would say 10,933 feet per minute. So when it's circling and a minute goes by, that's how far it is moving. It's moving 10,933 feet per 1 minute. And last but not least, we have an area of our sector, what you did do in geometry. So 1/2 times our radius squared times our angle. Now again, my angle's in radians. Because of our angles in radians, it's just easier to move when you're finding length. So sprinkler on golf course sprays water over a distance of 70 feet. So again, that's important to us. And rotates 120 degrees. So if you really wanted to see like what we are doing here, this is saying that this angle right here is 120 degrees, even though that looks like acute, and we have a radius of 70 feet. So I'm asking for what is this angle here. So the first thing you want to do is change 120 into radians. So remember that's pi over 180. So that into radians is 2 pi over 3. So now we can use this equation. So now it's going to be area of a sector is 1/2 times my radius squared times my angle in radians. So if you put that in a calculator, you get 5,131. In this case, our units are feet, and we're talking about area that's two-dimensional, feet squared. So it covers 5,131 feet squared. Okay, that was a lot. Have a wonderful day.